Hi, this is a film called Atomic Symbols Revisited. It's supposed to give you another chance to look at atomic symbols, and really it's just a couple of examples about how to write atomic symbols based on some information we're given about some atoms. Okay, so hopefully you know about the symbols A, Z and X, you understand them, you know what the difference between an ion and an atom is. Okay, if you don't know those things, these examples will seem difficult, and a lot of year 11 and 12 will seem difficult. So before you move on to trying to do this sort of stuff, make sure you've got those basics really down and you understand them properly. Okay? By the end of this film, hopefully you'll have just done a few examples of these things, so you'll have practiced the A, Z and X system of notation for some atoms and for some ions. Let's start with a potassium atom. Now bear in mind this is an atom. We're being told that it hasn't gained or lost electrons, so it's going to look like it does in the periodic table. It's got the symbol K. You might expect something different for an element with the name potassium, but it's K and it's based on its Latin name, Kalium. Okay. If you look it up, the smaller number of the two, remember we are following this format where that is the symbol of the atom. We're going to write the proton number or the atomic number there, and we're going to write the mass number up there. So 19. Remember the proton number is always the smaller of the two because it's just protons, whereas this one's protons and neutron. Okay. Potassium has a mass number of 13 if we round to the nearest whole number. Okay. It's got no charge because it's an atom, so that's how we'd write it in symbols. How many subatomic particles has it got? Well, it's got 19 protons. So that's its proton number or its atomic number. How many electrons has it got? Well, it's got 19 because it's an atom and not an ion. How many neutrons has it got? Well, we can use this number to find that, but we can't just say that's the number of neutrons. Remember, this number here equals the protons plus the neutrons. Okay, so we can find neutrons by saying A minus Z, and in this case that's 20. 39 minus 19 is 20, so 20 neutrons. Okay, easy peasy maths, quite easy rules, but forget them and you can't do the questions. Here's an ion, okay, we're being asked about. So first and easiest thing to do, I suppose, is to find the symbol for ion. Okay, it's an ion, so it's been told it's got a 3+ charge, so we can write that up there. What does that tell us? It means it's lost electrons because it's positive. How many has it lost? It's lost 3 because it's 3 positive. Okay, iron, if we look it up on the periodic table, atomic number 26, mass number 56, rounding to the nearest whole number. Okay, how many subatomic particles does it have? Well, protons is easy because it's the proton number or the atomic number, 26. Electrons a bit trickier now because this is an ion, so it's lost electrons compared to what it normally would have. It would normally have 26 to equal the protons, but it's lost 3, so 23 electrons. And this number minus that number is always the number of neutrons. This number has got nothing to do with electrons, so it doesn't matter if electrons are lost or gained. It won't affect the number of neutrons, so if we take that away from that, we're left with 30 neutrons. And finally, one last example. What particle would form if sulfur lost 2 electrons? Now we're not being told if it's an atom or an ion, but we are being told it lost electrons. So it's not going to be an atom, it's going to be an ion. You might remember me saying in the previous film that atoms like to get full shells. Well, this one isn't, and it's just a little bit of an example to show you that that atoms don't have to get full outer shells. We can make them gain or lose electrons against their will. Okay, so anyway, bearing that in mind, sulfur, looking it up, element number 16, okay, or its atomic number is 16, or its proton number is 16, mass number rounding to the whole number is 32, so we know there's 16 protons because that's the proton number. This atom we're being told is going to lose 2 electrons to form this particle, so instead of having 16 it's going to have 14 electrons, and remember this number minus that number is the number of neutrons, so there's 16 neutrons. Let's just finish off the symbol for this particle, right? It's lost 2 electrons, therefore we know it's got a positive charge because it lost, and a 2 plus charge because it lost 2. Okay, that's just about it about atomic symbols. A good place to go next might be the film about isotopes, which deals with different forms of atoms and how we can write the symbols for them.